I wanted to have a quick look at solving a simple reciprocal trig function across a certain domain. So we're not looking at general solutions, we're looking at specific solutions. And by the end, hopefully we'll be able to understand what's going on with this diagram down the bottom. So firstly, the one thing I would say is in order to understand this mini lesson, you're going to need to understand how to solve trig functions like sine, cosine, and tan, because now we're looking at reciprocal trig functions. So if you feel like you've got a bit of a grasp of general trig functions between certain domains, you can hopefully extend your understanding to reciprocal trig functions. Maybe the first thing we want to get clear about is what all these terms mean. So let's just be clear. So the secant of x is 1 over cosine of x. So it's the reciprocal of cos x. And let's just be clear on all the other ones as well. So you've got the cosecant of x, which is equal to 1 over sine x. And then you've got the cot of x, which is the cotangent, which is 1 over the tan of x. Now, the way I remember it is there's a co in each of the relationships. So cosine goes to secant. There's one co in there. That co is for cosine. And then for cosecant, that corresponds to sine. So there's one co in there. That's for cosecant corresponding to sine. And then cotangent corresponds to the reciprocal of tan. So that's sort of how I remember how each of them correspond. There's a co on one side of these relationships. So that should be helpful there. Okay, so what we have here is solve the equation secant of x equals 2, where x is between 0 and 2 pi. Well, straight away we can write 1 over the cosine of x equals 2. Okay, now if we do a bit of rearranging here, we can actually turn this into a solving of trig, a regular trig function. I'll do this in 2 steps just so it's super clear. If I multiply both sides by cosine of x, I get 1 equals 2 cosine x. Then if I divide both sides by 2, I get cosine of x equals 1/2. Now, that's actually something we hopefully know how to solve. So basically, what we're going to do, the way we solve these, is we draw up a little axis. And we're going to say cosine of 1/2. So we need it equal to 1/2. Now, we know that the following properties of our trig functions. This A stands for all. All the trig functions are positive in this quadrant. Sine is positive here. Tan is positive here. And cosine is positive in this quadrant. So tan of 1/2. So we're asking ourselves, where is cosine equal to 1/2? So that's positive. So it's going to be positive here and here. Okay, so the question is, what is the exact value where the cosine value is equal to 1/2? I don't really care about the sine value. I'm just interested in the cosine value being equal to 1/2. Okay, and this is a matter of knowing our exact values. And I can tell you that this is going to be at pi on 3. This is sort of our reference angle, pi on 3. Okay, so if this is pi on 3, well then this angle here, remember between 0 and 2 pi. So remember 2 pi is all the way around the unit circle, all the way around. So this angle here is actually going to be 2 pi minus pi on 3. Because we're looking for our first two positive solutions because our domain is between 0 and 2 pi. So we can actually say that x is going to be equal to, well, we're going to go around the circle. We're going to hit at pi on 3, and then we're going to hit at 2 pi minus pi on 3. So this is going to be at pi on 3 and 2 pi minus pi on 3. Well, let's just do the arithmetic there. So that's going to be 6 pi on 3 minus pi on 3. So that's going to be at 5 pi on 3. Okay. So there's actually our solutions. That's the answers that we're after. X is equal to pi on 3 and 5 pi on 3. And if we come down here and have a look at these graphs here, we can see this red line is actually the secant of x. Okay, and we can see that it actually intercepts, and rather I drew that in the wrong spot, this red line. So this secant here is secant of x, and this blue line is the line y equals 2. So where do they intersect? Well, they intersect at pi on 3 and at 5 pi on 3, which is what we said up here. Now, you might have noticed what we also had was a situation where the cosine of x was equal to 1/2. Well, that's what we've drawn in the green line here. So the cosine of x is this green line. And you guessed it, this black line is y equals 1/2. So we've sort of got two sets of graphs going on here. But you can see that the cosine of x equal to half is equal to half at pi on 3 and 5 pi on 3. So hopefully that clarifies how to solve a simple reciprocal inverse function. Basically, you want to turn it into a regular trig function and then solve it from there.